Hi everyone. Today we will see how is the distance between planets are measured. So it is not possible to measure it directly using a meter tape. That on one end we have Earth and another end we have Moon, and we can directly calculate it. It's not possible. Sorry, we can directly measure it. That is not possible. So there is a method called parallax method. So using this method, we calculate the distance between multiple many planets. We can calculate distance, large distance basically. So what is parallax? So if you look into the definition of it, so it says parallax is a apparent change in position of an object when it is viewed from different points. So there is a word called apparent change. Apparent change means it appears to be. It appears to be. It is not real. It appears to be that the position of the object is changed when viewed from two different points. Let's say keep a pencil, keep a pencil in front of you, and do one thing. You first time you look at the tip of the pencil from right eye. Okay, you will find, okay, now close your right eye, open your left eye, and again look at it. You will find the position of the pencil has changed. Why? Because the background has changed. Why? The background had changed. So it is appearing that the position of the object has changed, but actually it has not. Okay, it is still same. So that's why I have used the word apparent change in position of an object. Okay, now coming to the second part, this was from the explanation point. So what do we do here? Okay, and how are we going to calculate it? So here what we will do. So let's say this is moon, this is moon, this is moon, and this is earth. Okay, and this is earth. So initially what I said, that you close your eyes, one eye you close, and uh, you look at the object from second eye, from the right eye, and another time you close your right eye and look at the object from left eye. Okay, so we will here the observer is two different place. So both of your eyes are acting as an observer. So this is earth, let's say this is earth. Okay, so you are observing moon from here. Let me change the color. You are observing from moon from here, which is point A, and another time you are observing the moon from here, which is point B. Okay, so the distance between observer AB, AB we call it as a base. AB is what? Base. Okay, so if I am looking from A, so this is the line that forms. Okay, and I am calling it as a distance D. I am calling it as a distance D. Okay, similarly this will be also be distance D. Why? Because the distance is so large, and the angle theta, let's say this is theta, this theta will be so small, I'm not going to neglect it, that the both the distance will be D, both the distance will be D. You cannot say okay, this is D1 and D2. This is not possible. Even if you see D1 and D2, then we are assuming that D1 is equal to D2 is equal to D. Okay, so instead of writing D1 D2, I will just write D. Okay, now AB is the base, D is the distance. D is what? distance. Okay, so if I consider AB to be an arc, AB AB to be an arc of a circle of of dia of radius, radius d. Okay, so can I write, so according to mathematics, in mathematics p2 write arc is equal to radius into theta angle, angle which is covering. So here I can write AB is equal to d into theta. Okay, AB is what? Base. AB is what? Base. So can I write d is equal to AB upon theta. AB upon theta. AB is base. Okay, and sometime we also base, so it also written as d is equal to b upon theta. B is the base. ठीक है, चलेगा. Now there are some limitation. So here theta has to be in radian. Okay, so there is some conversion that you need to know. 1 degree is equal to pi upon 180 radian. Pi upon 180 radian. Okay, similarly 1 degree contains 60 minutes. 60 minutes. ठीक है, 1 minute contains 60 second. 60 second. Okay, so you can calculate accordingly. So here you can say 1 minute is equal to pi upon 180 into 60 minute. Okay, 1 second is equal to pi upon 180 into 60 second. ठीक है, so these are the simple conversion formula that I have explained. So you can say, okay, here you are calculating the distance between earth and moon. How so here you can see, the larger the distance will be, the smaller the theta will be. Okay, the larger the distance will be, the smaller theta will be. Okay, so if we get, so it's okay, we can calculate the distance between earth and moon using two diametrically opposite points on earth. Okay, but if there is a very far star, let's say, not star exactly, there's some planet, not I won't take example of a star. So here what we do, we use the ellipse. So earth rotate in a ellipse, right? So we use 2 points of earth. Let's say there is a star or some planet very far away. So once earth is here, okay, so we will measure the angle. We will consider this to be d. Okay, once earth goes here, then we will again, this one become d, this one become d, this becomes our baseline. Okay, baseline, we got theta, then we calculate the distance. D is equal to b upon theta, I guess. Yes, d is equal to b upon theta. So we are using, first it depends what is our baseline. So we maximum can take help of, or if possible we can also just, I wanted to explain you that if the planet is very far, then we need to take help of the orbit of earth. Okay, then after I think this is enough. This is what in most of the problems what you will get. You will get the theta value. Okay, you will get the baseline value. You will have to calculate the d. In case you have any doubt, you are free to comment it. Please let me know. Okay.